Okay, so these are just a couple, about 8 problems. We'll do as many of them as I can video-wise, based on kind of compound triangle trig stuff, okay? And so this first problem, we're going to try and calculate the CN tower. 2 observations are made from street level. From the first point, the angle of elevation to the top of the tower is 66, and from a point 75 meters closer to the tower, the angle of elevation is 72. So you're going to actually try and find the height of the tower. What I find helpful all the time with these is just the picture. Okay, so we're going to have the CN tower here. Okay. And ideally it would be straight. Okay, and then you're going to be at street level, like this. The CN tower is going to be there. Okay. And you're going to make 2 observations. So the first one's going to be back here at, let's say, point A. And what you see to the top of the CN tower, you have an angle of elevation, elevation being up, and the angle of elevation is going to be 66 degrees. Okay? And then you're going to walk 75 meters closer to a new point, point B, and you're going to look up at the tower. Right? And that angle of elevation is going to be 72. Okay, and your job is to figure out what the height of the tower is. Okay? And sorry, one more thing, 75 meters. Okay, and so what we did yesterday when we worked through this ourselves is that you just try and start solving for information, right, as best you can. So sometimes when you build a little momentum with these problems, it just kind of unravels, right? And so what I can say here is I can figure out what this angle is, theta. Theta is going to be 180 minus the 72, okay? Oops. Okay, and so we're going to get 108 there. So theta is going to be 108, okay? Which then means I can solve for the other angle up top of the triangle. Okay, we'll call that one. Try to color code everything so you can clearly see where everything goes, right? So beta is going to be the 180 minus the 108 you just found, minus the 66 in the other corner. Okay, that's going to be 6 degrees. So beta is going to be 6 degrees. Okay. Up top. So now, typically what we said is you're going to try and solve for whatever the shared component is between the 2 triangles when we're dealing with these compound situations, right? So if I could solve for that thing, you know over here that because we drew the CN tower straight, you're going to meet the ground at 90 degrees. Okay, and so if I can solve for that pink side length, then I can use SOHCAHTOA to solve for the height, h. Okay, so that's what we're going to do now. If I extract that little triangle, so just visually, like you have these 2 points, A and B, and then you have, they create a triangle, right? Something that looks like this. Okay, and down here is 75 meters. What I'm looking for is this side length here on the side. Okay, that's shared. I'll highlight it pink so it's clear. You're going to look for that because you also know up top this is going to be 66 degrees. This is 108. Oops. And this is 6 degrees. And so what you're going to do is it looks to me like I have some of these sine law loops sitting here, right, where I can go like this. So that's going to be point C up top. Sorry, I'll label that, let's say. Okay, and so what I can do is I can go sine of C over little c is equal to, I'm interested in the pink piece over there, that's little side length A. So sine of A over A. Okay, so angle C is 6, so I'm going to go sine of 6 over 75 is equal to the sine of A is 66 over little a, which is what I'm looking for. And at this stage, you can do what we called cross multiplying in the past. So you're going to get a sine 6 is equal to 75 sine 66. And then to get a by itself, you can divide both sides by sine 6. Okay, and we're going to be left with a is equal to, let's divide out, 75 sine 66 over sine of 6. Okay, and so side length C, that pink piece from our triangle, is going to be whatever that calculation is. So 75 sine 66 divided by sine of 6. We should get 655.5 meters. Okay. And once we have that, now you've got that pink piece we talked about earlier. Okay. And if I were to draw another triangle now, one with the CN tower in it, right? So if I extracted the other triangle, it would look like this now. I'd have the CN tower, who has a height of h, okay? And you have your angle of elevation from the beginning of the problem to be 72 degrees, okay? And this is point B. And now you know this is the pink piece here, right? So you know its side length. Okay, and its side length is 655.5 meters. And so what you're interested in is solving for the height, right? The height is the opposite side length against the angle 72, and 655.5 is the hypotenuse. So I can go sine of 72 is going to be equal to opposite h over 655.5. And so h is going to equal 655.5 sine 72. And so h is going to equal 655.5 sine 72 is going to be 623.4 meters. So you say, therefore, the height of the CN tower is 623.4 meters. Okay, so that's it. These compound angle triangle questions, or compound triangle questions, right? These word problems, they mix in sine law, cosine law, and SOHCAHTOA, and your goal is to try and find the thing that's shared between them so that you can use it to pivot and find the thing that you actually want. So this is a good example of that here, okay? I'll try to do as many of these as I can, but that's it for this one.